moment of inertia. So that's why I is equal to now of, so Ke is equal to of, so here I can just write it here as mk square omega square. So where mk square is equal to sigma mr square, or for an mn I can just write it r1 square plus r2 square plus r3 square up to divided by n. Multiply and divide by n, no change in the expression. So where n is what? Where n is the number of particles, each of mass m, elladruddu mass m. Okay, this whole particles, now I can just write it as m is divided, so now I can just write it, I can just define it as m, which is a product of m into n. So k, what happens that time? K is equal to r1 square plus r2 square plus r3 square up to, okay, so to the power okay, divided by n to the power 1 by 2. Hence I can just write it, radius of gyration, I can just write it as definition as it is the square root of mean square distance, square root of mean square distance of the particles, okay, mean square distance of the particles of the body from axis of rotation, So radius of gyration is the square root of mean square distance. So square, you can see that is k is equal to root of r1 square plus r2 square plus r3 square up to rn square divided by n. So square root of mean square distance of the particles of the body from where? From the axis of rotation. Okay, so radius of gyration, it is, radius is nothing but it is length. So now its dimensional formula for the radius of gyration is m0 l1 t0. This is the dimensional formula. Okay, whereas the moment of inertia I is equal to mr square, so its dimensional formula is, I can just write it m1 l square t0. What happened? Voice is not clear, screen is not shared. Okay, so now, okay, so I can just write it, so I is equal to mr square, so m1 l square t0. Okay, so what happened? Now also voice is not clear. So
ಬ್ರೇಕ್ ಆಗ್ತಾ ಇದೆ ಸರ್, ಕೇಳಿಸ್ತಾ ಇದೆ, ಬ್ರೇಕ್.
ಇಂಟರ್ನೆಟ್ ಸ್ವಲ್ಪ ಸ್ಲೋ ಇದೆ ಅದಕ್ಕೆ. So moment of inertia, now I can just write it as, so units of moment of inertia is kg, because mass is expressed in meter kg and the radius is expressed in meter square. So moment of inertia SI unit is kg meter square. Okay, so moment of inertia expression is kg meter square. Okay, so moment of inertia is a scalar quantity. Why does it is a scalar quantity? Because the value of I about an axis remains unchanged by reversing its direction also. ಈ ತರ ಹೋದ್ರುನು ಮತ್ತೆ ಈ ತರ ಹೋದ್ರುನು the direction remains same. Okay, so it has no direction. So moment of inertia is a scalar quantity because it has no direction. Okay, so since it has no direction, it is called as scalar quantity. Now, once you know this moment of inertia, let us try to understand what is the physical significance. So, physical significance of moment of inertia. So, moment of inertia is analogous to mass. So, moment of inertia is related to angular, that is rotational motion, whereas mass is linear motion. You can just say that it is analogous to rotational moment of inertia is analogous to mass, whereas mass is related to linear motion, moment of inertia is related to rotational motion. Okay, so now according to Newton's law, you know that you have studied that body continues to be state of rest or state of motion in a straight line unless an external force acts upon it. This property of matter is known as inertia. You know that, I have stated that in the beginning of this class. Okay, so a body always resists an external force tending to change. That's what again I said it. So now here I can just say that a body free to rotate about an axis opposes its change, state of rest or state of rotation. So now I can just say that greater the moment of inertia, greater is the, so there you have to apply the force in linear motion. Here you have to apply couple. What is couple? Two equal and opposite forces acting on a body. One is acting like this and other is acting in this direction. So it yields a rotational motion. Okay. So moment of inertia, you know that it doesn't depend only on mass. It depends on the distribution of mass on the axis of rotation. Either the entire mass it is not depends. It depends on the where the mass is rotated, where the mass is located here. M3, M4, M5 ಈ ತರ ಎಲ್ಲೆಲ್ಲಿ masses locate ಆಗಿದೆ ಅದರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿರುತ್ತೆ. Okay, understood? So now I have given certain analogies there other day. So that is mass. So now let us give some of the analogies in the translatory and the rotational motion. So the analogy is, now let us consider translatory motion and here rotational. Translatory andre linear anta. So now translatory motion alli mass andre, rotational motion alli moment of inertia. Displacement here is an angular displacement theta here. Velocity in the translation here it is a omega, angular velocity. Linear velocity is here, the linear acceleration is a, here angular acceleration alpha. So linear momentum is given by mv, here angular momentum is given by I omega, because mass into velocity, here momentum I into omega. Now force is here mass into acceleration, here force is here mass into acceleration, here that force analogy here it is torque that is given by I alpha. So here it is kinetic energy of m1 v1 square of mv square, here it is of I omega square. So these are the some analogy between the translatory and the rotational motion. Okay, is that clear? Another doubt idya? Is there any doubt? Is there any doubt? Is there any doubt?
No, sir.
ಅರ್ಥ ಆಗಿದೆಯಾ? ಅರ್ಥ ಆಗಿದೆಯಾ? Whatever I have said now?
Yes, sir.